All right, today we're going to talk about systems of equations with linear model world problems. But first, we're going to do a warm up. So, 160 students attended a dual language school in which students are taught only Spanish and some are taught only English. The survey was conducted in order to analyze the number of students studying bio and math. The results are shown below. Okay, so S is the students taking Spanish, B is the circle taking bio, M is the circle taking math. Find the number of students in the school that are taught in Spanish. So that is 17 plus 10 plus 40 plus 28. Add those together, you get 95. Question B, find the number of students in the school that study math in English. So these 40 and 28 learn it in Spanish, so it's going to be 12 plus 20, and those mathematics students learn it in English and not Spanish. This one here, find the number of students that study bio and math. So the key word is and math. So that's going to be 12 plus 40. Okay. Write down, what does this mean? Oh my goodness. So n is the number of items. It's going to be a whole number. Okay, M union B, everything that's in M and B. So 8 plus 10 plus 40 plus 12 plus 28 plus 20. That's M union B. And then S intersection of that. So where does this circle intersect the spaces we just said? And it's going to be 10, 40, and 28. We add those together because 10 plus 40 plus 28 is the stuff with intersecting in the S that is in this union. You might want to hit pause and replay to hear that again. Okay, M intersection not in. Okay, so B intersection M is only the 12 plus 40, and then intersection of not being in circle S is just 12 because this is not in circle S. The 40 is in circle S. Okay. Next, a student from a school is chosen at random. Find the probability the student studies mathematics. So 12 plus 20 plus 40 plus 28 gives me 100 over 160, which is the total number of students. Find the probability the student studies neither bio nor math. So neither bio nor math is 17 plus 25 over 160. Find the probability that the student studies Spanish given that the student studies bio. So all the bio students, 8 plus 12 plus 40 plus 10, gives me 70. And the ones that study Spanish is 10 plus 40, and that's in my numerator. You might want to hit pause and rewind to see this again. Okay. So here we've got this question. It costs a manufacturer $12,000 to set up the machinery to produce some toasters, and for the initial cost, and then 100 toasters produced costs $1,000. The toasters are sold at $25 each. So determine the cost of production, C of n, where n is the number of toasters. So here I have my initial amount that we pay to start the process, and since 100 toasters costs $1,000 to produce, that means that means for every single toaster it's going to cost $10, because 1,000 divided by 100 is going to give me 10. So $10 for each toaster. So that's my equation for production. Determine the equation for the revenue. Well, for each toaster you're going to earn $25. Here's my revenue equation. So now we're going to make a graph. So in order to make our graph, I need to enter the equations. So here we have 12,000 plus 10x and 25x. And if I just do a normal graph, you don't really see much of anything. I see part of one of the graphs. So this scale is not good at all. Now they've told you that for x, or n, it's going to be between 0 and 1500. So I'm going to go to the window, and I'm going to change the x max to 1500. Okay. And then the y max, well, how do we figure out what the y max should be? Well, you know that if n is 0 or x is 0, the smallest number is going to be 12,000. So let's pick a big number like 40,000. Okay, then we can graph this and see what it looks like now. Okay, so we're trying to graph this, and this is what we're gonna do. So, and as you can see, I've already graphed this here. But how do I know what points to plot? So I want to get a table. So if I do second graph, then I'm going to get a table. But as you can see, here we have 12,000, here we have 0, 25, it goes up and up and up. Now, to figure out where these intersect, this is going to take me forever, right? Especially if my scale here is 0 through 1500, right? You'll get old and have gray hairs before this gets up to that 1500. So, what do I do? So if I hit second window to get the table set, I'm going to change the delta TBL to 100. And when I do that, if I hit second graph to get a table, now it's going to go up by 100s. So when x is 0, this first graph here is going to be at 1200. Okay. So let's look at the scale. So the x-axis, I was supposed to go between 0 and 1500, like it had said in the instructions. So I thought, okay, well, looking at how many spaces there were here in this grid, I decided to count by 200s. And then here, I decided to count by 10,000. So that's 10,000, 20,000, 40,000, 60,000. And I used this table information to help me get this. So the steps that I did are right here. You might want to hit pause. I changed the x max. I changed the y max. I changed the delta TBL to 100. And then I had second graph to get a table. You might want to hit pause to do this. Okay. So question D says, how many toasters are needed to produce and sold in order to get a break even? So basically, when this function and this function are equal is when it's break even. So I made these two functions equal to each other. 12,000 plus 10n equals 25n. If I subtract n on both sides, I get 12,000 equals 15n. Divide both sides by 15, and I get n equals 800. And you can see on my graph that this is going to intersect here at 800. You might want to hit pause if you need to copy this down. Question E says, calculate the profit or loss made when you sell 400 toasters. So to figure out the profit, you're going to take the revenue function minus the cost function. So the revenue function is when I take the 25n and put 400 into that. And the cost function is when I take this 12,010n and plug in 400 in for that. Okay. And as we can see, by plugging that in, I end up losing 6,000 if n is at 400. And if I plug in 1,500, then I end up getting a profit of this. You might want to hit pause if you need to look at this some more. Okay. Self-adhesive label packs are produced, and here's the cost function. The revenue function is here. Graph the function on the same axis and label the graph. Okay, so basically what I did was you hit y equals, and we type in the equations, 3x plus 20, and the other one is 5x plus 10, and as you can see, my graph window is not set up for this, so I need to change it. So with values like 10 and 20, I know that this doesn't need quite such a crazy window. So if I just want a standard 10 by 10 window, I can hit zoom and 6 to get a standard window. Now, that's not really working very well, is it? So let's change the window. I'm going to hit window, and I'm going to change the X max to, let's just change it to 50. Well, I guess here in this example I did it 20, so let's make it 20. And Y max, I'll make that 50. And then if I get the graph, it looks much nicer. I can see the intersection right there. Okay, so then if I hit second graph, I'm going to get a table, and then I'm going to get these values. Now look here, my delta TBL goes by 100, and which isn't going to work for me to graph this data. So I have to go second window. I'm going to change the delta TBL to 1. Okay, and then I can hit second graph, and then my table is easier, and you can see that this data matches what's on the calculator. So and so I made a scale of each of these big marks by 1, and each of these marks I went up by 5, 10, 15, 20. Okay, and then I took the data from here to figure out points to plot. So like 0, 20 is this dot right there. 1, 23 is this dot here. 2, 26 is this blue dot here. And then 0, 10 is this pink dot. 1, 15 is that pink dot. 2, 20 is this pink dot. Okay. Question C says, for what value of n is a profit made? So whenever you're at 5 or greater, you're going to make a profit. Question D, how many self-adhesive packs are needed to be pre-produced and sold to make a profit of $100? So once again, the profit is equal to the revenue minus the cost. So my revenue function is 5n plus 10. The cost function is 3n plus 20. Remember, we're subtracting, so minus 20 here. So 10 minus 20 is going to give me negative 10. And 5n minus 3n gives me 2n. Simplify this, and we get 55 packs. You may want to hit pause to look at this some more. Okay. Two-way adapters sell for £7 each. The adapters cost $250 to make, with the fixed cost of $300 per day, regardless of the number made. Okay, so if they sell for £7, then my revenue is 7 times x. it costs $300 fixed fee, and then it costs $250 to make each adapter, so 250 N. Okay, so looking at this, I know the Y max needs to be bigger than 300, so I set it up to 800, and the X max I set it up for 100, and the delta TBL I set it for 10, and then that gave me this data here. You might want to hit pause to check your data with your calculator. Okay, on my scale here, I went by I made each mark by 10. So here this is 10, 20, 30, 40, 50, 60, 70, 80. Okay. On my scale here, I went by hundreds. So 100, 200, 300, 400, 500, 600. Okay. Let's look at question C. Determine the break-even point. So that's when the revenue equals the cost. So question C. Yeah, so let's find the break-even point. So I make these equal to each other. So the profit has to be 0. Right? So I added 300 on both sides, and then divided by 4.5. Okay, might want to hit pause. Question D says, how many adapters must be made and sold each day to make a profit of £1,000? Okay, so using the profit equation, we know the profit's going to be 1,000. We're taking our revenue equation minus the cost equation, and then we simplify. Okay, next question. Okay, a new novel is being printed. The plates require for the printing costs €6,000, and after the printing costs after which the printing costs this amount per 1,000 books. Okay, and it sells for this amount. Okay, so if it sells that much per 1,000 books, then it's $325 per book. Okay. Second window, I made my delta TBL 250. My window, I made the maximum 20,000 and Y max 20,000. You may have to play around with these numbers. Just because I'm giving you right now these numbers, kind of when you play around, you're going to see what's going to be big enough to see the intersection. Okay, you may want to hit pause to look at this. Okay, so on my scale here, I went by every 2 big lines, I made it 500, so 1,000, 1,500, 15,000, 20,000, and same thing here. Every 2, I went 5,000, 10,000, 15,000, 20,000. Okay. Next question. Okay, Waverly Manufacturing produces carburetors for their vehicles. Each week is a fixed amount for running the factory. You can see that fixed amount there. Each carburetor costs $13.24 in materials and $14.80 for labor costs. So added together, that's going to be $28 per carburetor. Okay. The Waverly is able to sell the carburetors at $70 each. So 70 yen is my revenue function. The profit is the revenue function minus the cost function, and here is our profit function. Okay, now we want to make a graph of this. So we know that um, the y min has to be bigger uh, than 2,000, right, or 21,000, so 2,100. So I just made it 10,000 and see how that would. And I made the max 100. I made the delta TBL 10. Okay. Then after I got this data, and then I saw that the intersection point here is when x is 50. Okay. So I made my scale here for n 10, so 10, 20, 30, 40, 50, 60. And I made the scale here by 1,000. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, and so on. Okay. The break-even point is when I make the two functions equal to each other and solve for n. Question II says find the profit when n is equal to 125. And question III, find the number of carburetors required to make a profit of 1,300. Okay, you might want to hit pause if you need more time to look at this.